A polar function is given by r equals f of theta, which means nothing, equals -1 plus sine theta. As theta increases on the interval where theta is between 0 and pi over 2, but not including those numbers, that will play an important role. Which of the following is true about the points on the graph of r equals stuff? I hate the fact that they have to throw in that f of theta just to confuse you. Don't let it confuse you. Don't let it confuse you. What we're going to do is we're going to make a table of values, and we're going to use the values that would normally be used in a reference chart. Even though we're not supposed to include 0 and pi over 2, I'm going to, you can't stop me, and then I'll explain what's going on in a little bit. So we have theta here, we have r here. I'm going to plug in 0, I'm going to plug in pi over 6, I'm going to plug in pi over 4, I'm going to plug in pi over 3, and I'm going to plug in half a pi. That's supposed to be 3, and I'm going to plug in half a pi. All right? Now, the function that I'm supposed to use is sine theta minus 1. So if I were to plug in 0, I would get 0 minus 1, which is -1. Sine pi over 6 is root 3 over 2 minus 1. I'm not going to lose sleep over the math behind that. Pi over 4 is going to be root 2 over 2 minus 1. Pi over 3 is going to be 1/2 minus 1. And then pi over 2, when I take the sign of that, is 1, and 1 minus 1 is 0. So in the limited space that I have, what I want to do is I want to graph these values on a polar plane. Now, oh man, I really did a bad job giving myself space. All right. Here's 0, here's pi, right? All of these guys represent the values that I want. So really the only things that I need here would be this is 0, this right here is pi over 2, right here where d is, right? So you would be pi over 6, you would be pi over 4, you would be pi over 3. So I'm going to try to recreate that over here in this very sloppy picture that I have. Very sloppy. All right. All right. Let's graph this guy. At 0, -1. So 0, I'm going to have it go to -1. So let me make just some arbitrary circle, and I know it's going to look awful. It could be worse. All right, so that 0 represents the radius of 1. Let me get a different color. So at 0, -1 means I don't go in the positive direction, I go in the negative direction. We have a dot right there. At pi over 6, which is this way, I'm going to go root 3 over 2. Root 3 is, I don't know, 1 point something. Okay, so what's important is as my theta gets higher, this number gets smaller. So root 3 over 2 is 1 point something over 2 minus 1, which is going to give me a dot kind of close to the x-axis, but going in the opposite direction. Okay, like so. If I were to plug this in, it would get closer. If I were to plug this in, it would get closer. And then at 0, I hit back. So what's happening, and it's really hard to tell because my picture is just simply not doing it justice, is first off, these guys don't count. But even if they did count, what's happening is it starts off at the x-axis, goes away, but gets closer to the x-axis. So as theta is increasing, my points are getting closer to the x-axis. So the points on the graph are above the x-axis? No. The points on the graph are above the x-axis? No. The points on the graph are below the x-axis? Yeah. And are getting closer to the origin? That is true. The points on the graph are below the x-axis, true, and are getting further away from the origin. That's not true. So this requires some polar coordinate knowledge, which is pretty cool because of polar. And it's the answer is C. The answer is C.